Hi, I'm Professor David Farina. In today's lecture, we're going to be talking about the solar system, in particular planets beyond the solar system, also known as extrasolar planets. Let's get started. So we have observational evidence of planetary and solar system formation around other stars. And we look only to the nebulas to start to see these things happening. So if you look here, you can see a bunch of them. There's one, here's another, there's one more, another, and here's another bunch all over the place. We've got these little tiny pockets, these little tiny eggs, they're called, evaporating gaseous globules. And if we zoom in on these things, and if we look at them just right, we can see that we have many young stars in this particular constellation of Orion, the Orion Nebula. We can see these little dust disks with little stars forming inside of them. And we think that these are probably areas where planets are being formed right now. Now, we have some star types called T Tauri stars. These T Tauri stars can be directly imaged by the Hubble Space Telescope, and you can see the dust and gas of these T Tauri type stars, which are early in their formation. The dust and gas is kind of at the same orientation towards the Earth, and so we're seeing these edge on. And here's the disk of dust and gas. This one's very clear, disk of dust and gas. Here's this one, and here's this one. And you can see that the amount of solar radiation is shooting out of the top and bottom of each of these different T Tauri stars. And so once again, these are these dust disks that we think are the same as Earth would have looked like about 4.6 billion years ago. So we can use these as analogs for our solar system. Some extrasolar planets can be observed indirectly. And by indirectly, we mean we don't actually take an image of the planet itself, but we can see its effect. We can see its gravitational effect on its parent star. And so this is kind of like a dog or dogs that are kind of walking their owner. So the question is, who's walking who, right? So the dog is flying around on its leash, and the woman is trying her best to hold on to the dog. And no matter what she does, the dog is going to tug on her one direction or the other, and she's getting whipped around by that dog. So the dog in this case is like the planet. The woman is like the star. And we can actually observe this wobbling effect that planets have on their parent stars. And of course, the bigger the planet is, the more wobble we're going to get, the easier they will be to detect. So as of now, the wobble technique is mostly revealing the bigger of the planet types, the Jovian-style planets. Now, of course, the proximity of those planets, how close they are to their parent star, also plays a role. And what we're actually finding is some very interesting planet types known as hot Jupiters. Big like Jupiter, but close, maybe even much closer than the planet Mercury. So these are not actually observed in our own solar system, at least not in today's solar system. But we think there may have even been some hot Jupiters here in our own solar system in the past. Maybe early in the solar system's formation, but we're not sure. If you'd like to learn more about extrasolar planets, please check out the exoplanet.eu catalog. This is an excellent up-to-date catalog of all of the extrasolar planets that we currently have known of, and it will provide you the ability to look way deeper into this interesting topic. So here's more of the wobbling technique, and we can see the effect that these planets have on their parent stars. Now we also have some evidence for extrasolar asteroids. So the dimming of parent stars by debris that's found in orbit around the star itself. And if we're looking at them once again on that same plane, that same orientation where Earth and the plane of that solar system are in line, we might see the debris from extrasolar asteroids. We can even see the wobbling effect of these as well. And so I'm interested to find out more about this. Maybe we can even determine some composition and other masses and determine other types of object out there just by studying light curves from other worlds. There are some various direct detections of planets that are now starting to become possible. So here's a picture of this particular planet. It's 2M1207b, and it orbits about 77 astronomical units from its brown dwarf sun. So this planet is a direct picture of an actual planet. This is a very rare thing that we can accomplish. They need to be very close to us, and they also need to be rather big planets usually. Now, what type of light would you prefer to view in? Infrared actually is the best because we can cut through a lot of the starlight that would normally be found in the visible spectrum by viewing it in the infrared. And planets themselves can glow in the infrared all on their own. They don't need to actually reflect sunlight in this case. So infrared is the best way to go because we're going to get the planet heat rather than just reflection of sunlight. So you'll notice that we have Earth here for scale, and we've got a number of super Earths. So super Earths are thought to be planets that are very similar to Earth but bigger. And of course we're looking for these Earth-like worlds because if we can find one, it's possible life could exist on those Earth-like worlds. So terrestrial planets are a lot harder to find. They're very tiny, and they don't create so much wobble on their parent stars. So we generally use the next technique to find these, which we deal with something called a light curve. So what happens with our light curve is that we are dealing with a star and planetary system that is, once again, on the same plane as Earth's visual path. And so we see the planet actually moves from a position somewhere over here, and it's in movement across the face of its parent star. When the planet is in front of the star, it drops the amount of light that we see from that star as seen on this graph. The light curve goes down. Then it travels across the radius of that star, as seen here, and eventually the light curve intensity picks back up again, and the planet has now done what's called a transit. It's gone across the face of that star. And this gives us a ton of information. It gives us the size of the star. It gives us the size of the planet by looking at the slope here of these lines, here and here. And it gives us its overall brightness of this star. This from here to here gives us a very, very important piece of information about the star itself, how much energy it's giving off. And finally, when this happens, we could even potentially get some light that passes through that planet's atmosphere, and we can use spectral analysis to look at that star's composition, then take a look at the planetary atmospheric composition and compare the two spectrum, and what you end up with is a spectrum that looks just like a spectrum of our atmosphere. If we can find water vapor, if we can find oxygen in the atmosphere, it's very possible life on this world could exist. So these are a number of different orbits in orange of various different exoplanets that have been discovered compared to Earth's orbit in white. And finally, this is a plot of the masses of planets. Once again, here's the Earth for scale and comparison. So 1 semi-major axis, and this is planet mass in terms of Jupiter masses. Notice Jupiter is right here on this chart, and you'll see here's a patch of Jupiter like normal gas giants, and then there's a patch of Jupiter like, but much closer, hot Jupiters. Hot versus cold. So here we've got the Earth-like planets. We've got 1, 2 of them, but they're very hot. We've got super Earths. Here's many super Earths, Neptunes, and Jupiters. Notice there's a lot more Jupiter-like planets, but that's not because they are actually more abundant. It has to do with the discovery techniques we have. The bigger the planet is, the easier it is to spot, and so our data is skewed towards the bigger planets. Thanks for watching this video. I hope you enjoyed our discussion on planets beyond the solar system, exosolar planets. If you did, please hit the like button at the bottom, click subscribe, and hit that bell at the bottom if you'd like to find out whenever I make a video. Thanks again. Have a great rest of your day.